Hello, in this video, I will talk about creating a post builder for 5x mel. Uh, I have a question regarding some example to how to create a post builder for Siemens 840D control. One of the things that with respect to NX, with the Siemens NX thing, the Siemens being the own company, with respect to all the Siemens control, they have everything perfect. So you can open any of the simulation files with that closely matches the kinematics of the machine, and you can go into the first tab, go into make sure that whatever the kinematics you have, if it's table head, depend on it. So for example, this one I'm going to talk about because this gentleman asked about table Mel. So this one reflects what we're talking about. We got a Z-axis rotation, 360 rotation. We got a A-axis tilt, minus 115 to plus 115, plus 115 angle. Back in the day, before the invention of RTCP and 3D coordinate system, there used to be a rotary axis offset. Wherever the pivot, the center line of the pivot, the tilt table pivot, and then the intersection of the Z-axis table, the intersection point is called the pivot point. That's where we tell the offset in the post builder. If you do that, then you have to make sure that MCS you set it up in the NX. So this is where we put that in. So mostly one of the most common control is Haas. If it's inches, you go and put one of that 1/8 offset for VF2. That's one of the common controls. But again, it depends on the offset. What do you got from the top of the C table to the center line of the A-axis tilt, the intersecting point. So nowadays with RTCP, you don't need all those things. So it's zero. Well, second thing you need to look is so all these things, travel limits. As you can see, these are just namesake. You don't do this here. You do it in the kinematic chain. So that's where you define all the travel limits. In the home, you can put it at 0, 0, 0. Fourth and fifth. Again, you can, depending on your rotary axis, you can configure the stuff like the plane of rotation, all this stuff you can configure. The default, again, all these things mostly comes from a kinematic chain. Same thing with here, depending on your plane, the plane of rotation, G17, G17, G18, and G19. That tells you what your this one, and based on that, you will get the stuff. You can take any Siemens control from the template that closely mimics your kinematics and do that. So again, fifth axis, this is your complete C rotation. It's full contouring. For the fourth, for the tilt, make sure you put in whatever you want. Sometimes it used to be 15, and that number is minus something. So you make sure whatever the number mimics, you put it in. So the second important thing is, that's why I pull up a part that's close enough to have everything to tell you with 5-axis contouring. That's our surface, the pink surface that I highlighted. You can see that we can do a 5-axis contouring where we use the cycle 832, or in the FANUC it's G43.4 and 43.4 and 43.5, depends upon what you want to use. You want to use the vectors. So so here in your definition, you can define all that. What are you using your Troyari? Whatever you don't need it, you can take it and pull it in this term. So now with the fan, okay, it's the same thing. It's I can do a what are the inches you want. You make sure the inches are millimeter. You take, if you have a UDE, enable the UDE. You see different events. Then you go into pick up based on your kinematics of the machine. So let's go do that table machine. And here you go and pick it up from the library. Again, 840D is such a powerful control. With the FANUC, you got a 30i advanced. It will give you most of everything. All right, with the cinematic, let's go back and open the cinematic again. Again, for the cinematic cycle 800 is for a 3D coordinate rotation. So 3D coordinate system is what will you do is once you define your local offset G54, then you do one more MCS underneath it and just define it as a local coordinate rotation. So all this is the main skeletal structure of the post builder fuel operation start sequence, the toolpath event. Every event and event handler is all defined here. The motion types, it's all defined in here too. So the again all that every single one of them will go one by one of the tabs. But let's go and look at what we need to do here and that define that the operation sequence. So the last video, the same file, I took the same file and just bring in the part and copy the operations and use that same template. You can look at the last video to how to create this one. Is such an easy thing. Just bring in the similar operations and just use it, customize, modify it to what your operation is. As you can see, I went in and pick up that cut area, define the vector. So we have example to how to use G54, and then we set it up below that local CCs, do a CCs rotation for a 3D coordinate rotation for Fanicus G68.2 and G68.2, and then for cycle 800 for a cinematic. So if you go in there, make sure that you select the phase, the strategy. If you want to define your strategy for client parent space, if you define on the angle where which with respect to XC, how do you want your the toolpath to come in at 90 or 0. So now once you got this one, you want to copy paste it. Now here you can go in copy this and do it for that next phase. So once you generate the toolpath, if you don't that's why you can change all your the blank thickness and number of passes and the cut angle from XC. So we have the so this is the blank the highlight I'm showing. So this is the blank. Okay, it's a round stock. So it's been held in from the bottom through the cap screws, like 6 cap screws, and located with the diamond pins. The top face, the side face. Okay, this side, this side. So now we have all the examples of all the different angles. Before, back in the day, when you don't have a 3D coordinators, every time you change your local MCS to put it where you want to make sure X, Y, and Z, the plane that you're selecting, the Z is perpendicular to basically the parallel to the tool axis. Now with the 3D coordinate rotation, you just pick up a 1M G54 and then have a local MCS with a CC's rotation below it to make all the toolpath. Then for as an example, we'll do the streamline. Again, like I said, it's one of the templates I pulled up. You can see how we did pull the template and we define the. So right now we are doing an example for a G43.4 or a 43.5. G43.5 on a FANUC is based on a IJK vector. Again, it's a machine independent. You can use that IJK if you are supposed to define G43.5. You can use independent of machine kinematics. With the G43.4, you will get that A, B, and C depending on your order axis configuration. Again, but therefore you need to define the table based on your table setup. Even the table, the center line of that, the tilt center line on the Z-axis rotation. If it's the offset is different, you need to again reconfigure the post and everything. So here we go into streamline. Keep everything new. Okay. Now you need to define your point. So let it come and the tool axis. Okay, now we have an example of 5-axis toolpath to cut out this surface. So now we'll go and generate all what we needed for again regular planar milling, 3D using 3D coordinate rotation, and also G43.4 or ceiling cycle Troyari orientation, and that we had to switch it off with the Troyari transformation off. Let's make sure that we have all the examples we have right now. Okay, again, just based on the round stock, let's verify the toolpath before we go and start cutting. So what we need to do is we'll do it in like I think a 2-path series. It's 15 minutes. Okay, so this right here. So a lot of haircut moves because I want to show you guys the example of different tool paths, how we can able to configure the the post for that. Let's make it fast. So we're cutting all 4 sides. We can select the so once we have all the examples of the toolpath what we need to have the post written for 3D coordinate rotation and also the G43.4. We can now go into the post. Let's configure all those the post stuff what we needed. So if let's go into the new post. Okay, so mostly this video is only for 15 minutes. I will come back to the second part of this one. So soon I will